So it's a real pleasure to be here. My name's Paul Maddox. I'm going to be here today talking about CI/CD and automation of software release processes, mainly in context of serverless and containers. So, a bit of background about me. I've worked at AWS now for nearly 4 years. Started off 16 years ago in the industry. Started off as a software developer. Have also worked in operational SRE type roles, and then moved into systems architecture. I'm a developer at heart. I develop a lot in Go, a lot in Java, some C, Node, etc. My contact details are also here. If ever you want to ask questions around serverless containers, development best practices, etc., feel free to reach out to us. Also, if you want to tweet a picture of me on stage with my Twitter handle so that my boss knows I'm working and not at the beach, that's cool as well, because I'm pretty sure he thinks I'm just spending this whole time at the beach. Who's your boss? My boss is a guy called Julian Lepin. Cool. So agenda, what are we going to cover today? We're going to focus heavily on automation, right? Automation of your release processes and pipelines. We're going to cover off some of the best practices for how to build and test your applications. We're going to talk about how to deploy those applications. And this is where the talk kind of splits a bit. And we're going to talk about some best practices for serverless deployments and best practice for container deployments. And then we're going to talk a bit about how can you improve the developer experience for your software automation, right? As we move to a world of microservices where we're spinning up projects all the time, what's that developer experience like in your organization? If I'm a developer and it's my first day at your organization, I come and I want to start a new development project. What does that look like for me? Do I need to go and set up my own Jenkins box, my own Git repo, etc.? How do I get all the best practices and learnings from this organization, etc.? So we're going to cover kind of scaling out pipelines at a bigger scale at the end of this. So there we go. So I want to start with a bit of history about Amazon. Amazon, if you look back to Amazon in 2001, 2002, Amazon, the retail e-commerce site, was a huge, great big monolithic application, right? It was very, very painful for us back then. We had, lots and lots of development teams, centralized deployment team, not much automation in place, right? Getting code out from a developer's laptop into production in front of customers took way longer than we wanted. So we're a very data-driven company at Amazon. We did a study, and we sent out a study back in 2009, so nearly a decade ago now, to try and work out where the inefficiencies were in our organization. Why was it taking us so long to get code into production? Oh, I need to stand over here. And surprise, surprise, it turns out we were just waiting. So if you look at a really, really simplified version of a pipeline here, taking code from a developer's laptop, writing the code, building the code, testing, deploying to prod, the actual time wasn't spent in any of these particular workloads. It was actually the waiting time in between. So if we put this in relative terms here, it was taking minutes to write the code and then days for it to sit around waiting to progress to the next stage of the deployment. In total, it was taking us weeks. It was taking weeks to get code from laptops into production. We knew if we could drop down those long waiting times between our teams, then we could really bring down that time it takes to get code out. And we could get that down to hours. So to do this back in 2009, we needed new tooling. A lot of the kind of tooling that we wanted to do didn't exist. And we built a whole load of tools for things like pipeline visualization. Much like the pipeline software you've probably seen in Jenkins and Bitbucket, etc., we built something very similar called pipelines internally. We built another tool called Apollo, and Apollo was the tool that does deployments for Amazon, right? And it takes an artifact as its file, and it knows how to do, zero downtime rolling updates. It knows how to do blue-green deployments, and it prevents developers having to think about how do I do that kind of safe deployment, and lets them just hit the deploy button. So we built these tools and went through a process of improvement. And the net result was that, after this program of work, we had thousands of teams at Amazon doing development work, all building microservices, all with, dev, test, prod type environments. And I think this number's from 2015. We were looking at around 50 million deployments a year. All right, around 1.6-ish a second deployments. And these aren't big feature releases for most cases. These could be a typo, these could be a documentation change, a schema change, etc. We don't tend to bunch up these releases into big feature releases. But we learn a few things along the way on this journey about what good development tooling should look like, some key tenets. So number one, tooling needs to be self-service. If I need to go and raise a ticket with an operations team to get some EC2 instances, etc., right, we failed as an organization, right? Cloud takes you beyond that. It allows you to spin stuff up on demand, self-service manner. So the tooling should be self-service as well. Combine that with best practices. So a CI/CD pipeline is an amazing place to put in checks and automations for best practices in your organization. Things like security checks. If you have to go through an InfoSec review on your application every time you need to deploy, how much of that is manual? How much could be automated? What if you could put those automated checks in every single developer's pipeline in your organization in a scalable way? So pipelines are a really, really good place to bake in best practices in your organization and take all those learnings that you've learned over the years and apply them in an automated fashion. But it's also got to be able to do that without being too restrictive, and that's a fine balance. Like, how do you prevent people getting frustrated? So number one, it needs to be technology agnostic. If you're building CI/CD tooling or putting in place CI/CD tooling, and it's tied to a particular development language, or a particular architecture, or a particular framework, the technology is going to move on and advance, and then people are going to look and use other solutions and not yours. So the tooling needs to be technology agnostic. And the number one rule of this kind of release automation, process management tooling, is it needs to be the path of least resistance. If it's easier for me to take out a credit card and go and spin up my own AWS account rather than go through the corporate process, I'm not going to follow it, right? I need to move fast. I've got deadlines in a lot of cases, etc. So how do you get to the point of path of least resistance? And as a concrete example of this, as a developer in Amazon, if I want to start a new development project, there's a portal I can go to. And it asks me, what programming language do I want to use? What kind of architectural decisions do I want to make? And it will go and deploy a CI/CD pipeline, a source repo, staging environments, production environments, etc., that get me most of the way there. Now, we don't restrict that at Amazon. As an engineer in Amazon, I'm pretty much free to use whatever technology I want, whatever programming language I want, right? There's a lot of freedom there. But the reality is, because this easy solution is the path of least resistance, it's the one that most people take unless they have a real reason they need to innovate and take something further. So these are kind of the core lessons we learned around good tooling. And we took all that and we applied it in a load of AWS services for our customers. So we have a load of services in this kind of CI/CD space, things like AWS Code Pipeline, AWS CodeBuild, etc., that really help you build up these kind of capabilities in your org really quickly. So in my role, I speak to a lot of companies. I speak to a lot of companies of all different sizes. And this is fairly common, right? When you speak to a company and you say, where's your build server? Like, how are you doing this today? What does it look like? And it's like, oh, yeah, it kind of sits under the desk and, Bob set it up and he's left our company now, don't touch it. And this is kind of to Aaron's point in the previous talk about things like Jenkins. Jenkins is a great tool, but it's very easy to get a lot of really complex business logic in Jenkins or other similar toolings. The AWS approach is actually to break up our tools into modular tools that do one thing and one thing well. So CodeBuild, really good at building. CodePipeline, really good at providing that visual overview. So there's no excuse for this kind of scenario anymore, and hopefully with some of the services I'm going to show you in the next couple of slides, you can see if this rings true to your organization, how you can move on from there. So the first service I want to talk about is AWS Code Pipeline. AWS Code Pipeline allows you to visualize complex workflows in a really nice, simple way, right? Check in from source code. Whenever something in source code changes, apply this process. Maybe go and deploy a test environment, run a load of load tests, tear down the test environment, get a manual approval from someone in my organization, etc. This is a concrete example of a really simple pipeline. So it's set up to trigger from GitHub on the left here. And whenever a change happens in GitHub, we're using CodeBuild to actually build our code, run our unit tests, for example. And then when it comes to staging, we have CloudFormation deploying our staging environment for us, and then actually deploying the code onto the instances that have been deployed. So this is a really simple overview of a pipeline. In this one, we've got a manual approval stage. It may be that your organization doesn't trust you enough yet to actually go fully automated end-to-end, so every developer check-in results in a production release automatically. Right, that's the goal for most organizations, but if you've got a history of, not doing testing well enough, or failed rollouts and deployments and emergency rollbacks, it can be hard to build that trust, and you may still need those manual approval gates in there. So you can do that with CodePipeline. So this is a really, really good way to just design, orchestrate, and visualize your release workflows. Let's talk a bit about some of those services in the pipeline. And one thing I should call out before I do is, the services I'm going to talk about, you can plug them into a pipeline, you could swap them out for Jenkins. It's kind of modular, right? It's like a set of Lego bricks for your pipeline. I'm going to show you the AWS toolings, but there's loads of integrations with loads of other providers like Jenkins and TeamCity, etc. So we're going to talk about a couple of types of automation. First, how to automate build and test. And then we're going to talk about how to automate your infrastructure and deployments of your serverless and containerized applications. So when we talk about build and test, traditionally, if you've used something like Jenkins, you may be used to having a Jenkins instance and then like a build farm that goes out and does all your builds. That's cool, but it's a lot to maintain, right? VMs, instances, operating systems, Jenkins, etc. How do you deploy that? How do you upgrade it, manage it, patch it, etc.? CodeBuild takes a different approach. You give AWS CodeBuild your build job, and it will scale up behind the scenes, and it will run your build jobs for you, and you just pay per minute. So really, really sweet way of just farming out your builds to this massively scalable cloud. What's cool is that it comes pre-populated with a load of different build environments. So when I set up my new build project, I can choose my operating system and runtime. So the runtime pre-installs a load of tooling for if I'm doing Android development, it can install like the Android development toolkit, the ADK and stuff. Java, I can choose what Java version I want, etc. If these don't fit your requirements, you can just give us a Docker container, and that can be your build environment. So really nice and flexible there. And again, you're just paying per minute that your builds are running. So how do you control this? How do we keep this technology agnostic, right? How does CodeBuild know how to build your application, how to test it, etc.? You have a file called the build spec file, which sits inside your application repo alongside your code. And in this, there's a load of hooks. And you tell CodeBuild, okay, here's the commands you need to do to install or pre-build. So maybe before I build, I want to run npm install to fetch all my dependencies. Maybe I want to run some tests and unit tests, etc. This is a Go example, running some Go unit tests and linting and stuff there. So this is a really nice, convenient way for developers to be able to tell the CodeBuild service, here's how you build my application. The end result? You get a nice console in the AWS Management Console where you can go and see the status of your builds. You can see the logs from your builds, etc. So there's actually, if you are using Jenkins and don't want to use AWS Code Pipeline, there's a really nice plugin for Jenkins that can just farm out all your builds from Jenkins straight into this. So super convenient. So this is a great place to run your builds, run your unit tests. What about actually deploying the infrastructure and deploying your applications? So how many people work at an organization today where you have these production environments and they're these super shiny, amazing machines, right, that everyone tweaks, everyone takes care of, and like so much attention and detail goes into your production environment. But then when you look at your dev and test and staging environments and integration environments, they look like something that's been built in a school science fair. And one day, I got this picture of Flickr with commercial license and stuff, but one day, these people are going to be in the audience or something, or their parents are, and I'm going to be very embarrassed. But this was one of the first results for school science fair. And this kind of rings true. I've worked at a lot of organizations before joining AWS where, bugs are introduced consistently, because the staging environments, the integration environments look nothing like production. And this is a really, really quick way to lose trust, right? If you want to go fully automated, you need to build that trust in your business. So consistent environments matter. So a really, really common approach is infrastructure as code here. AWS has our CloudFormation service. There's other services out there in the open source world like Terraform. Essentially, they allow you to take an AWS architecture, load balancers, EC2 instances, all those kind of resources that make up your architecture, and put them in a template, and then deploy that over and over and over and over again. So really, really cool. What's interesting is if you start checking in your architecture template into version control, along with your application, you can deploy that in the same pipeline. You can actually go back in time in version control and see, okay, what's changed over time? Like, when was the last firewall rule added to my architecture, etc. And you can actually start doing unit tests and integration tests on your infrastructure as well as your application. So really powerful concept. Highly recommend if you're not doing infrastructure as code at all today, have a look into CloudFormation. It can just help automate those manual processes. So as an example of this, if you're using containers today with ECS, we publish a reference architecture that allows you to spin up a whole ECS cluster, all the best practices, scaling, networking, etc., with the click of a button. And you can just go and straight to this GitHub page and spin that up, and it's got some example microservices, and you can be up and running with containers in minutes with this. Cool, so infrastructure as code, CloudFormation. How do we actually get our applications on these instances? And this is kind of where the talk diverts a bit. And we're going to cover a bit of containers and a bit of serverless and the different approaches there, because they require different approaches. So let's start off with containers. One of the really nice things with CodePipeline is it has a direct integration with ECS. So it can actually go and deploy your containers straight into a running ECS cluster for you. There's like a native integration there. You can use it for Kubernetes as well. There's not the native integration, and you need to take the approach that Aaron showed in the last talk around actually using a Lambda function there to do a bit of the legwork. Here with ECS, it's fully integrated. So in this case, we've got a source repository, which could be code commit or GitHub. And to build our container image, so actually take the Docker file, build the container image, we're using CodeBuild. You could use Jenkins, like you could swap out, these are interchangeable modules, and then CodeBuild will upload the container image into our ECR, our container registry, and then once that's done, it can go and deploy it straight into ECS. So this is actually a native integration. If I want to set up a pipeline that does exactly this, these are the kind of steps I go through in the AWS console. So first of all, my pipeline needs a source. So this is where I choose, is it GitHub, is it code commit, for example? What's the repository name? Which branch do I want to monitor? Any changes that happen are then going to trigger through this pipeline. The next step, I choose the build provider. So here in that drop-down list, there's other options like Jenkins, etc. Here we're using AWS CodeBuild, and here we'd go through those previous options I showed you where you choose your build image, etc., and set up those options. Finally, the deployment provider. Here you'll see options like deploying to Beanstalk, deploying to CloudFormation. Here is the native integration with CodePipeline and ECS. And this will just find your service called Sample Web App and update it to the latest container version. And that's all you need to do. So really, really simple integration, gets your containers flowing through nicely, and you can obviously build up those pipelines over time, add more complex logic, like doing load testing, for example, deploying to integration environments. What about serverless? How does this work with serverless? How best to integrate serverless into our pipelines? Is anyone here using Sam, AWS Sam? Any people? Okay. AWS Sam is probably the coolest way to deploy serverless applications. Okay, so it allows you to describe a serverless app in a YAML file, a small YAML file. So when we first started with Lambda and serverless and API gateway, people were developing their first Lambda function. Cool, everything's easy. Once you start developing a more complex and advanced serverless application, you end up with lots of moving parts. Lots of Lambda functions, lots of API gateway integrations and stuff. How do you deploy that? Back when we first launched all of this, a lot of people use CloudFormation. if you try and describe the average serverless application in CloudFormation, you get a template about that long. It's not a nice thing to do. SAM simplifies that. So it's an extension to CloudFormation that just allows you to describe your serverless app in a really, really concise way and deploy it over and over again. So this is an open source specification. You can find the specification on GitHub. And this is an example. This is like a concrete example. So here we've got a SAM template. If you've used CloudFormation before, this should look fairly similar. So we have a resources section. And this resources section is where all my Lambda functions and Dynamo tables and my whole architecture sits. And in this case, we've got a function called getHTML_function. That's an arbitrary name. And it's of type AWS Serverless function. We tell it where to find our code and what the runtime is. Is it Node.js? Is it Java, for example? And then the events that we want to trigger our serverless function. So in this case, we've got one event, and it's type API. And we want to mount this Lambda function at slash. In fact, slash anything. So anything the person puts after slash in the URL. And with any HTTP method. So get, post, put, patch, etc. So this is all I need to do to define an application, right? A simple one-function application. And when I deploy this with CloudFormation, it's going to create for me my Lambda function, the API gateway, the mapping between it, all the IAM permissions and roles, etc. One really cool thing you can do with SAM as well is actually develop locally. So we have something called SAM Local that allows you to take a SAM template and your serverless code and just run it locally. So it uses Docker behind the scenes on your local machine to actually run your Lambda functions locally, simulate API gateway locally, and allow you to develop and test really, really quickly, like nice, fast, iterative cycle, debugging and stepping through, etc. All those kind of normal development methodologies. And you can just do it all locally, and when you're happy with it, push it into the cloud. So I wanted to show you the easiest way to set all this up for serverless, right? How I go about starting new serverless projects. And I was going to do this as a live demo, and unfortunately I've been really let down by the Wi-Fi in here. Apparently the access points can't keep up with like a couple of thousand of us geeks or something. But so I'm going to fall back to slides in this case, and I apologize for that. But this is a product in the AWS Management Console called CodeStar. And every time I ask about CodeStar and I ask people, have you seen this, have you played with it? Not many people have. And it's kind of similar to the internal tool I mentioned at Amazon, where you go to start a new project, you choose your programming language, you choose what type of application you're writing and the architecture, and it deploys a best practice CI/CD pipeline deployment, all your tests, etc. for you. So when you first go to it, you get a chance to create a brand new project. And the first thing you see when you do that is those technology choices. So I can go in here and I can say, yeah, I want to write a Go application. It's a web app, and I want to run it on Lambda. In this case, I'm going to go through and pick a Node.js one. So I pick Node.js on the left-hand side and web application. And I've got an option at the top left here for writing a Node.js web app on serverless. I then get asked for the project details, right? Like, what's the name of the project? Where do I want the source to code to be stored? And in this case, CodeStar can create me a repo in either AWS Code Commit or just on GitHub as well. So in this case, I've chosen GitHub. And when you integrate with GitHub, so I go through a login with GitHub and it gets access to my GitHub account, etc., I can then choose whether I want CodeStar to create for me a private repo or a public repo. So in this case, I've chosen a private repo. And then you get a summary of everything that's going to be deployed for you. So that's all the kind of wizard that you need to go through, all the information gathering, etc. You give it a name and where you want the project to be stored. CodeStar is then going to go away, and it's going to create that source repo for you. It's going to create a build environment for you. So if you chose Node.js, it's going to run npm install and npm test and stuff to run unit tests. And it's going to write the build spec file that I showed you, the CodeBuild configuration file for you. It's going to configure it all, set it all up to automatically run your builds and tests. And then it's going to write your CloudFormation templates for you to actually do all the deployments. It's going to write that SAM template for you. And then it's going to set up things like monitoring as well, so you get best practice monitoring on error rates, invocation, latencies, etc. So you click Next. It goes away and it's created for me a GitHub repository. and I get the URL, and this for me as a developer is the main way I interact with this project, right? I check out the code, I make some changes, test it locally, etc., and then push back into the GitHub repo, and that's all I need to do to trigger a deployment. So I can go in and have a look at the GitHub repo, and you can see for me, CodeStar's created like a sample serverless application. It's a really simple one. It just serves up a static website in this case, but the code is there, and you can start playing around with it. You can see that build spec file there for CodeBuild and a few others, like template for the Sam template, and some docs below on what it does and the moving parts. So once that's done, it takes like 3 or 4 minutes, you get a nice dashboard for your development project. You don't have to use it. Like, all of these tools are pre-configured as best practice, but you can change and iterate on them as you go on. This dashboard that it creates for you is quite nice. It shows your GitHub issues and commit histories in one place. You've got your CI/CD pipeline on the right-hand side here, so you can watch it go through and modify and go through build and test, etc. And then you get your metrics and your logs as well, so you can see straight here, right from your project dashboard, what are my invocations and errors, and this demo app, I didn't really have any demo data. You also get a chance to add team members really, really easily. So you don't need to go setting up like IAM users, etc. for all your team members. You can just really easily add team members to collaborate on your project from here. So I think AWS CodeStar rocks. Like, it is the simplest way to get started with a serverless project today. It doesn't just deploy to serverless, it deploys to Beanstalk and a load of other options as well there. But I see this being used most for serverless these days. Okay, let's talk a little bit about where next. I mentioned a bit about the developer experience. What does it look like in your organization today when a developer wants to start a new project? What do they need to go through? Does it look like that CodeStar example, right? So CodeStar is a really, really good way of getting started with all those best practices, but you can't customize it. Right? You can tweak things after it's been deployed, but you can't bake in all of your best practices and have anyone that goes to CodeStar have like a custom tile for your application or your CI/CD pipeline. So how do you get all these best practices, bake them in a pipeline, and then make it repeatable? So let's talk a bit about how to do that. So when you build a code pipeline, you can do this graphically via the AWS Management Console. There's like a nice UI that will take you through, and you can add more and more steps, unit testing, integration testing, etc., to your pipeline. But that's not very repeatable, right? That's human manual interaction every single time. So one thing you can do is these pipelines, under the scenes, behind the hood, they're just JSON, right? They're described as JSON. So you can actually run, using the AWS CLI, once you've built your pipeline graphically, just go and dump out the JSON and get the full JSON for your pipeline. Once you've got that, you can put it in a CloudFormation template, right? And then you've got a CloudFormation template that when it's spun up, will spin up a whole dev environment with source repo, with all that kind of stuff, with the pipeline, with all your best practices baked in. So how do you distribute that CloudFormation template then? One option is to have like a wiki page internally, right? And put your CloudFormation template on there and have people spin it up. Not quite the best developer experience there. A better option is AWS Service Catalog. If you haven't seen Service Catalog, it allows you to create portfolios of products and serve them up in a self-service way to people in your organization. Those products are really just CloudFormation templates. So anything you can put in a CloudFormation template, you can productize and make self-service. So I can first create a portfolio. So Service Catalog, I may create a portfolio for my developers, for example. And this is a portfolio that all my developers will get access to, and it's got a whole load of different products or pipelines in there that they can choose from. So in this case, I create a portfolio called Internal Development. And then within that portfolio, I create my products. And in this case, it might be like CI/CD pipeline for Go serverless applications or something. And I can take that nice pipeline I've designed with all my sort of security checks and best practices, etc., and I can turn that into a product. I get a chance to offer things like support details, like who to contact when this goes wrong, for example. I get a chance to tag the resources that get created with this for cost control. And then I choose my template. So this is where you upload your CloudFormation template. And once you've done this, you've got your product. It's been bundled up. People can go and do this self-service. One really nice feature of this is the IAM permissions that are needed. So normally, if I wanted to say give someone here a CloudFormation template that spins up my pipeline, that user or that person is going to need all the permissions to create a pipeline, to invoke loads of stuff. Like there's some pretty lengthy IAM permissions involved there. When you're using Service Catalog, the user only needs permission to interact with Service Catalog. Service Catalog is the one doing all the deployment and stuff. So therefore, it's a really, really nice way of giving these developers environments that they can spin up easily without having to have loads of crazy IAM permissions. So I create my product. Then when a developer logs in, once you've given them access to that portfolio of products, they can just go in and they can see, okay, I've got my development environment here. I can just go and launch this, and I can see my existing ones that I've already launched, and I can spin them up and spin them down easily. So this is a really nice way of sharing those pipelines internally. So I wanted to wrap up and just sort of summarize what we've been over. We talked a lot about bottlenecks at the beginning and using automation in your software release processes to remove those bottlenecks. I always try to encourage customers to whiteboard out what your software delivery process looks like today. Try and work out which bits today are manual processes, which ones are the most expensive, time-consuming ones, and try and automate them and put them in a pipeline. Use something like CodePipeline, CodeBuild, great for automating and scaling out your builds and tests. For containers, if you're using ECS, CodePipeline's native integration with ECS makes it pretty trivial to deploy your containers. There's options as well for Kubernetes that we showed in the last talk. If you're using serverless, AWS Sam is a really nice, concise way to deploy your serverless applications, test and run them, develop on them locally, for example. And then as you get to a point where you want to scale this out and make your pipelines more self-service, have a look at AWS Service Catalog. So with that, I'm going to wrap this up. I'm going to be around at the front. If anyone has any questions they want to come and ask me about, I'm more than happy to hang around and answer questions. Thank you very much.